land on Earth. Both countries stopped these blasts after less than 24 tests. To avoid hitting friendly satellites or spacecraft with big, imprecise nuclear blasts, conventional firearms could be used in space. But if you were in charge of security outside of a space station, would a normal handgun even fire without atmospheric oxygen in a microgravity environment?
Gunpowder has its own oxidizer built into it, so it would fire. If you managed to get the firing pin to hit the end of the bullet, it would go off. Now, would it eject the slide and the next bullet go into the round, and would that work? That's a good question. I'm not real positive that it would fire more than a few times before it seized up and quit working.
A big part of the problem is that the metal-moving parts inside guns need lubricants to work smoothly. But the harsh extremes of space would probably cause the lubricants to fail.
If a handgun got in the sunlight, for example, it would get really, really hot, and the parts would seize together probably. If it were not in the sunlight, it would get really, really cold, and the parts would seize together probably. And lubricants just have a hard time of working in the vacuum of space. The biggest problem is they bead up. They turn into little balls because there's no gravity or any other atmosphere that it can adhere to.
Astronauts have demonstrated the same thing when they drink liquids in microgravity. Instead of flowing evenly, the liquids separate into a series of spheres. But there is one system that would work well for keeping away the bad guys in space: launching bullets with a railgun. Railguns use a series of strong magnetic fields rather than gunpowder to propel bullets. Current railgun projectiles can already race down range about 3 times faster than a bullet from an M16 rifle.
The idea of a railgun is you take a small pellet that's maybe metal, it may be plastic, maybe whatever, but you have to have it wrapped in aluminum foil because you complete an electric circuit between 2 long rails, and the magnetic field created accelerates that little pellet out the end of the rails, and it can accelerate it very fast, up to, some people believe, close to the speed of light.
Similar systems are at work in certain bullet trains and roller coasters.
We have a series of magnets, and the magnets propel an object, either a roller coaster car or this giant slug of a bullet you want to use to hit something in space, from one to the other, accelerating as it goes, and by the time it's reached a certain number of accelerators, a certain number of pairs of magnets, it's really going as fast as you need it to go.
Mounted on a large spacecraft, the railgun could become the naval cannon of the future. Long rows of powerful magnets could propel big projectiles to millions of miles an hour. But would that kind of gun be enough to take out an alien civilization before it could destroy Earth? A 100 years from now, spaceships at war may blast away with ultra-high-speed railguns that destroy targets without explosives. Just by slamming into the enemy at many thousands or even millions of miles an hour, they'll release incredible amounts of kinetic energy, the energy of motion. In 2008, the U.S. Navy tested the most powerful railgun that now exists. Using a series of magnets and strong electrical currents, it launched a 7-pound projectile at over 5,000 miles an hour. The gun's estimated range, when fully operational, will be 200 miles.
A slug, moving at 7 times the speed of sound, does a lot of damage. It's one of those things where you're glad it's on our side.
It's the kind of weapon that could really do some damage to the capital city of a violent alien civilization.
You can envision the big mothership having a railgun that runs along the periphery from one end to the other, and it could shoot a very large projectile like the size of a car or a bulldozer. that you could then accelerate on that railgun maybe 10%, 20% the speed of light. And that much kinetic energy could likely destroy the whole city. I mean, that's a lot of energy.
But such an advanced railgun is obviously a long way off. So are there any kinetic energy weapons that could come to space in the near future? Remember the telephone pole-sized rod pummeling the underground bunker in our moon battle set 100 years from now? Well, that weapon, known as a rod from God, is simple enough that it could show up if a war comes to space in the next few decades. A small rocket boost would get the aerodynamic rod started.
It's basically just a big metal rod, and it'd probably be something like tungsten or some really strong and heavy metal that you can put in orbit and drop it onto the wherever you want, whatever the target is, from space, and just let gravity accelerate the thing.
Gravity's ability to speed up an object and increase its destructive power can be seen in a weapon from centuries past. The trebuchet, which is a type of catapult used to rain down destruction from on high.
Gravity acts upon an object like this rock at a rate of 10 meters per second squared, roughly 30 feet per second squared. So if we take it and drop it, it's fallen for less than a second, has not come close to reaching 30 feet per second. But take that same rock, launch it with the trebuchet, higher, further, it will have a chance to accelerate to 30 feet per second, 60 feet in the second, 90 feet in the third second. When it hits, it'll leave a much bigger crater. This rock traveled through the air for about 5 seconds, which means that by the time it hit, it was traveling close to or around 150 feet per second. And with that added kinetic energy, it left a much bigger crater.
In the battle 100 years from now, the rod launched at the moon has an advantage over the rock from the trebuchet on Earth. Since the moon doesn't have any atmosphere, the rod keeps accelerating until it impacts the underground command post of the Separatist colony. It burrows into the moon rock and destroys the command post. But what if the Separatists on the moon return the favor and launch a rod from a space platform at Earth? Earth's atmosphere will slow the rod, but will it be enough to prevent a knockout blow to an underground headquarters on Earth?
When it hits the upper atmosphere, it's doing about Mach 25 times the speed of sound. It slows down as it comes down through the atmosphere, but if it were to hit the Earth, it would bore way down in there because it's going to hit at like 5,000, 7,000 miles per hour. So the amount of energy that's dumped in a very small space in a very short amount of time is equivalent to a small nuclear weapon.
Something like this would have a lot of penetrating power. It would be the